Subscribe our Nehra Classes YouTube channel to watch free live training sessions and to avail the membership facilities and additional perks, click the join button. Okay guys, so this is session number 2 of our ongoing RHCSA version 10 training, and in this session we are going to talk about the history of Unix and Linux, concept of virtualization, and installation of RHEL 10 in Oracle VirtualBox or VMware. So let's start the session with the introduction to Unix. I hope you can see this PDF. Before we start the introduction of Unix, let's first talk about the computer languages, because computer languages have played a vital role in the development of Unix and then Linux. All of you might be aware of the types of computer languages that we use: low level language, middle level language, and high level language. So what are the differences between these three? Low level language is also known as the machine level language. It uses zeros and ones for the instruction. Means it uses binary language. While the middle level language, that is also known as the assembly level language, it uses mnemonics to create the instruction. And the high level language is similar to our human language, and it is easily understandable for the humans but not for the machine. Some of the examples of the high level language are COBOL, Fortran, BASIC, C, C++, and Java. Here I am showing you the picture of comparison of these three. In the machine level language, you can see there a pattern of zeros and ones which is used there. In the assembly level language, we use mnemonics for the instructions. It is readable to human but not completely readable as the high level language. And in the high level language, you can see that it is completely readable to the human but not for the machines. So machine requires high level language to be converted into machine level language, and we use interpreters, assemblers for that purpose. Here I made a comparison between these three. You can go through this. I will provide you this PDF. Machine level language is not readable, it is a binary code, while the assembly level language is readable, it uses mnemonics. High level language uses a readable language like our English language. Machine level language is the lowest level, assembly level language is the low level, and high level language is the high level language. Machine language uses binary instructions directly executed by the CPU. Assembly language use mnemonics representing the machine instructions, and high level language abstract commands or the statements. Machine level language is not portable. It is architecture specific. Assembly level language is not portable and architecture specific, while the high level language is generally portable across different platforms with some exceptions. The development time for the low level language or the lowest level language very time consuming, dealing with binary instructions, while the assembly level language is more time consuming due to low level details, while the high level language is faster in development with the higher level abstractions. So you can check it. I'm not going to read all the features of these three. Now I'm showing you the picture. This picture illustrates the control and usability of different type of languages with the hardware. Let us suppose there is a microcontroller or microprocessor. So if we use machine level language provides a better control on the hardware or on the microcontroller or on the microprocessor, but it is less usable and less portable. While the assembly language is having the lesser control as compared to the machine level language, but it is slightly more usable. While the high level language, it is very usable, portable, but it has very less control as compared to the assembly level language and the machine level language. So for us, high level language is very comfortable because it is not only portable, but it is very easily understandable to us. But for the machines, it is not very efficient in terms of control. So machine requires machine level language. So that's why we use assemblers, interpreters, which convert the high level language into machine level language. Now we will talk about the involvement of these languages in the development of Unix. The development of Unix involved the use of multiple programming languages, including A language, A means assembly level language, B language, and C language. The initial version of Unix, which was known as Uniplexed Information and Computing Service, it was developed in the assembly level language, or we call it A language, for the Digital Equipment Corporation DEC PDP-7 microcomputer in 1969. So Unix development was started in 1969. The development team, including Ken Thompson, Dennis Ritchie, started working on Unix using assembly level language. So Dennis Ritchie, Ken Thompson, who were the part of the development team, they started developing Unix in assembly level language. However, they soon realized the limitations of assembly level language in terms of portability and ease of development. A language or the assembly level language was not portable. It was hardware specific. So because of that, they decided to make some changes in the development of Unix. So what they did, they started working on B language. To address the limitations of assembly language, Ken Thompson created a high-level programming language called B language. B was developed around 1970 and was influenced by BCPL. BCPL stands for Basic Combined Programming Language. B was used to rewrite many components of Unix, making the system more portable and easier to maintain. But B language had its own limitations, and some improvements were still needed there. So Dennis Ritchie realized that they need a more powerful and versatile language than B, and he started working on C programming language in early 70s. Then Unix, they changed the name to Unix. This was subsequently written in C and starting with the creation of new kernel. This move to C was a pivotal decision in the history of Unix, as C offered a good balance between the low-level control and high-level abstraction. The use of C made Unix more portable across different hardware platforms. So that's why, because A language and B language were not that much capable of creating the Unix, because there were some limitations, like they were not portable, they needed many improvements. So C played a vital role in the development of Unix. Entire operating system and their kernel was rewritten in C language at that time. The availability of high-level language like C also contributed to the development of a robust and extendable software ecosystem around Unix. So they not only created Unix in C, but many applications which are still in use, those are developed in the C language. So let's take a brief of this. Uh, the history of Unix dates back to the late 1960s when it was developed at the Bell Labs, the research and development subsidiary of AT&T. AT&T is the American Telephone and Telegraph. So the development started in 1969, where Unix was created by Ken Thompson and Dennis Ritchie and other people in the development team at Bell Labs in 1969. It was initially developed as a small multitasking operating system for digital equipment control, PDP-7 microcomputer, mini computer, sorry. The first edition came in picture in 1979. So the first edition of Unix was released in 1971. It was written in assembly language and designed to be a portable, multitasking, and multi-user operating system. The decision to rewrite Unix in C programming language later played a crucial role in its widespread adoption. So in 1973, the second edition was developed in C language. So Dennis Ritchie developed the C programming language, and the Unix system was rewritten in C, making it more portable, easier to maintain. The second edition of Unix, written in C, was released in 1973. In late 1970s, the Barclay Software Distribution, or we call it BSD, Unix was a variant of the original Unix developed at the University of California, Berkeley. The BSD version introduced many enhancements and improvements, contributing significantly to the development of Unix. In 1980s, AT&T released Unix System 3 in early 80s, followed by Unix System 5 in 1983. These commercial versions of Unix gained popularity in the industry. In 1983, Richard Stallman announced the GNU project. It was an effort to create a free and open source Unix-like operating system. The Free Software Foundation was established to support this initiative. So Richard Stallman announced the GNU project for free and open source operating system like Unix. Then in 1988, IEEE introduced the POSIX, Portable Operating System Interface. In 1991, Linus Torvald created the Linux kernel, and it became a popular Unix-like operating system, particularly in the open source community. Linux later on combined with the GNU utilities and libraries to form a complete free Unix-like operating system. So what is Linux? Linux is only a kernel. But when it combined with the utilities and libraries of GNU, it became an operating system which is known as Linux operating system, or we call it GNU. It is Unix-like operating system. So initially the kernel was created by Linus Torvald in 1971. And from then, multiple versions, multiple flavors came into picture. So this was all about the history of Unix and Linux. So in 1991, Linus Torvald, who was a computer science student at the University of Helsinki in Finland, announced his project to develop a new operating system kernel on 25th of August 1991. He released the first version of Linux kernel, version 0.01, and invited collaboration from the open source community. He kept the source code open for everyone. As you know that in 1983, Richard Stallman announced the GNU project with the goal of creating a free open source operating system like Unix. So by 1991, many components of GNU operating system were ready, but the kernel was still missing. So in 1992 and 93, Linux was combined with the GNU utilities and libraries to create a complete operating system. So the operating system kernel was developed by Linus Torvald, and the utilities and libraries were developed from the GNU community. So after combining all this, they created a complete operating system. This collaboration resulted in a functional and free Unix-like operating system commonly known as GNU or Linux. The first distribution came into picture in 1993, and after 1994 we saw a rapid growth in Linux. Multiple communities came forward to develop their own operating systems using the Linux kernel. Linux kernel 1.0 was released on 14th of March 1994. So this was the very first version. In late 90s, Linux gained popularity and acceptance in commercial environments, particularly in server and the enterprise settings. In 1998, Open Source Initiative or OSI was founded to promote and protect open source software. The term open source was introduced to describe software with freely available source code. So if open source is written somewhere, that means the source code is freely available to you. In 2008, Android came into picture. Again, Android is based on Linux kernel and it is very popular in today's world as well. So the Linux kernel became the foundation for the Android operating system, which played a significant role in the expanding the use of Linux on mobile devices. In 2010, containerization and cloud started adopting Linux. Technologies like Docker, Kubernetes, built on Linux containers, gained prominence in 2010, facilitating the development and management of the application in the cloud environment. Okay. Now we will talk about Linux and GNU. So the question which might be coming in your mind is, what is Linux? So Linux is both a kernel as well as an operating system, depending on what context you are using this term. Linux is just a kernel, which is the core component of the operating system that interacts between the hardware and the user. So kernel is just like a bridge which connects the user to the hardware. The work which you want to perform on your hardware, that is done with the help of the kernel. So kernel is the heart of the operating system. It is the core of the operating system which interacts with the hardware and manages the system resources. Practically, when people say Linux, they usually mean a full operating system like GNU or Linux OS. So if you are referring to the operating system, you should never say Linux. Linux means the kernel. Either you should say Linux OS or you should say GNU. So Linux is the kernel which manages the hardware. GNU, it provides utilities and libraries. And in any operating system which is having the Linux kernel, there you will find Linux kernel, there you will find the utilities and libraries and the user applications. So combining all these, we can have a Linux operating system. So is Linux just a kernel? Yes, Linux is only a kernel. The Linux kernel is a piece of software that communicates directly with the hardware, managing the resources like CPU, RAM, and the storage. It was developed by Linus Torvald in 1991 and it is open source. Open source means the source code is freely available to everyone. Linux is not the Linux OS. Most people use GNU or Linux distributions like Ubuntu, CentOS, RHEL, Arch Linux, and Debian. So if I'm saying Ubuntu, Ubuntu means Linux kernel and the GNU utilities and libraries, collection of all. So the distributions which I mentioned there is the bundle Linux kernel with the system utilities like GNU tools, libraries, and software. So Linux is the kernel only, and GNU or Linux OS means kernel plus the system tools. Now let me explain it with the help of a picture. It is the kernel, Linux kernel. It directly interacts with the hardware and it manages the resources like CPU, RAM, disk, network. If I say Linux OS or GNU, it means we have a hardware, we have a kernel, we have the system libraries, we have the GNU utilities, and we have the applications there. So it is the complete Linux operating system. So GNU means the complete Linux operating system. So this is the difference between GNU and Linux. Now we will start with the introduction to Linux. So as I mentioned earlier, in the history of Unix, it was started by Dennis Ritchie and Cam Thompson in 1969 at AT&T Bell Labs. They started the development in the assembly language first, then they tried to create it in B language, and then the entire operating system was rewritten in C language. They developed different versions for various hardware platforms like SunSpark, PowerPC, Motorola, HP. In 1991, Linus Torvald created a Unix-like system to run on Intel 386 processors. While still a student at the University of Helsinki, Linus Torvald started developing Linux to create a system similar to Minix. Minix was the operating system at that time. It was similar to Unix operating system. So Linus Torvald created the Linux kernel, and later on that kernel combined with the GNU utilities to form the complete Linux operating system. Now question arises, is Linux same as Unix? The answer is yes as well as no. Why yes? Because it has the same look and feel like any Unix operating system. It offers the ability to run nearly any program that runs on Unix systems. Why it is different? Because the heart of the system, the kernel, it has a lot of new features that go beyond the classical design philosophy of Unix kernel. So the Linux is more powerful. Linux kernel is more powerful as compared to Unix kernel. Therefore, Linux is Unix-like operating system, but not exactly Unix. Okay. I use the term GNU. What does it mean? GNU stands for GNU not Unix. GNU emphasizes a major project of Free Software Foundation, FSF, that really created the Linux operating system with many of its popular tools. Richard Stallman created Free Software Foundation in order to encourage the development and use of freely redistributable code. Free means the source code is available to the user. Open source means the source code is available to the user, but it does not mean zero financial cost. GNU public license defines the term and the conditions of redistributing the Linux kernel and other tools that make it usable, forming a Linux distribution. Now, I'm going to show you a picture of flavors of Unix. You can have a look at this. We have different flavors of Unix here in this picture, like Linux, HP Unix, IBM AIX, Mac OS, and Sun Solaris. All these are the flavors of Unix. These are derived from Unix. Now, if I talk about the flavors of Linux, you can find there Red Hat, CentOS, Ubuntu, Fedora, SUSE, Kali, Mint. So there are different communities which develop Linux. Red Hat is one, CentOS is another, Ubuntu is another. If I classify them, so there are two major categories. One is Debian based, another is Fedora based. Arch Linux is also there, but these two are major. In Fedora based community, you can find Red Hat, CentOS, OpenSUSE, Alma Linux, Rocky Linux. In Debian based community, you will find Ubuntu, Kali, Mint, and many more. In Ubuntu community, in Debian community, we use .deb files for the softwares. In Fedora based community, we use .rpm files. So we will talk about their differences in detail in the upcoming sessions. So here you can see we have multiple communities which are actually developing Linux. So there are more than 1000 flavors of Linux nowadays which are available to us free of cost. Some of the communities are not only developing Linux, but they are providing the support as well. So for those distributions, we require the license. For example, if we try to use Red Hat, it needs a subscription. So we need to purchase the subscription from Red Hat. If we want to test it, if we want to just use it, we can use it without subscription. But in case if we need the community support, in that case, we must have the subscription for our machine. Now we will talk about the features of Linux. Linux is highly secure. It is virus free because by default execute permission is not there for the files. So generally it is considered that it is virus free. It is highly stable. It is very easy to maintain, hardware independent, freely available, distributed OS. Distributed means we have lot of versions, lot of flavors available in the market. It supports almost all type of file systems. It is a multi-user and multitasking operating system. It is open source, means source code is available to us. If we want to make the modifications, we can easily do that. It is very easy to use. Customizations options are available. It is used in the educational projects. We have the community support there, and it handles the processes in a better way as compared to the other operating systems. So these are some of the features of Linux. Now let's proceed further. Now we will talk about the uses of Linux. You can find Linux in a smartwatch, and you can find it in the space station as well. So you can find it in supercomputers, space stations, servers, cloud computing environments, smartwatches, Large Hadron Collider, the machine which is running in Geneva, where the gold particle was invented, in-car entertainment, NASA, flights, space robots, smart cars, smart bikes, game consoles, air traffic control, smart TVs, stock exchanges, US defense, mobile phones, nuclear submarines, laptops, desktops, PCs, mainframe computers, you will find Linux everywhere, everywhere. Now we will talk about the Linux kernel. What is Linux kernel? The Linux kernel is the heart of the Linux operating system. It connects the user and the hardware through the shell. Shell provides the interface where user can execute the commands, and with the help of those commands, the operating system perform the task on the hardware using the kernel. So kernel pass the instruction from the user to the hardware. Let us suppose I want to increase the volume of my computer. So what I does, I go on the volume slider and I adjust the volume with the help of mouse. So what is actually happening at the back end? We are passing a message to the kernel that we want to either increase or decrease the volume. So what the kernel is actually doing, it is sending a signal to the hardware and it is adjusting the gain of the audio amplifier, and accordingly it is adjusting the sound there on the speaker. So this is how the kernel interacts between the hardware and the user. Generally in Linux, we perform the tasks using the command line interface. We generally do not use the GUI. So we are supposed to work on the command line interface only. That means we need to work on the shell. Shell is the environment where we execute the commands on the terminal. It is loaded on the terminal. So there are different type of shells that we use in Linux. We will talk about it later. So shell is nothing but a command prompt that we use in Windows. You can compare it. Actually, shell is the command line interface which provides us the option to execute the commands. So what is Linux shell? It provides a powerful interface to the Linux operating system. So you can manipulate the data and execute the several applications under the certain conditions. It is also known as the command line interface, or you can compare it with command prompt of Windows. Linux shells are available in different flavors. Which we want to use, we can. It totally depends on our choice. You must know which shell you are using and what can you do with the help of that particular shell on a Unix system. So knowing the shell is very important. It can be a bit difficult in the beginning, but since you get used to it, you have made a good friend that will help you to address every computational problem. So in the beginning, it will be a bit tricky or bit difficult for you to manage the machine with the help of the commands using the command line interface that is known as shell. But if you get used to it, it will be very powerful and handy tool. With the help of the CLI, you can manage a machine which is sitting at a very far place from you. So with the help of a few commands, you can easily control or manage that particular machine. And in this training, we will perform all the tasks using the command line interface or the CLI only. How can you access the shell? In order to access the shell, you must log in into the machine on the shell. So you should have a username and password there. The username and password will be provided to you by the admin or the root user. Root or the admin user is the user who has the super user privileges, and he can create the account for the normal users and he can provide you the username and password so that you can log in into the machine and you can perform the task. If you don't know the username or password, you can contact the system administrator or the relevant authority to obtain the login name and the password for the system. And after that, you can log in into the machine and you can execute the commands there on the shell. This is the file system structure in Linux. We have a root directory, which is the parent of all the directories. And under it, we can have /bin, /etc, /sbin, /usr, /var, /dev, /home, /lib, /mnt, /opt, /proc, /root, and many more. Each directory is used for a different purpose. Like /etc contains the configuration files, /var contains the variable data files, means the logs, Slash dev contains the devices. Slash home is the home directory for the normal users. Slash root is the root user home directory. So we have multiple directories under the root directory, which is the parent of all the directories, and each directory is used for different type of files. We will talk about these files and directories in the upcoming sessions in detail, and we will check what are the changes there in RHEL 10 as compared to RHEL 9. Okay, now let's proceed further. Now we will talk about the introduction to virtualization. What is virtualization and why it is important for us? So before I give you the idea about the virtualization, let's understand the physical machines or the bare metal servers. So we will talk about the architecture of the physical machines. Physical machine or physical server is actually a machine where we directly install the operating system on the machine and we manage the machine using this operating system. So physical server architecture refers to the design and the components of the physical server or machine, which provides the hardware infrastructure for processing, storage, networking, and the power management. This type of server or machine is commonly used in data centers and enterprise environments to host applications, databases, and services. Let us suppose you have a machine. So what is machine? Machine means the hardware. Like you will have the motherboard there, you will have the CPU there, you will have the read-only memory, you will have the write-only memory, random access memory. You will have the storage devices, secondary storage devices like SSD. You will find the network interface controller there. So we have the hardware. If we want to use this hardware, we need an operating system there. So we directly install the operating system on this underlying hardware, and on that particular operating system, we can install the applications like application 1, application 2, application 3, and so on. So this is known as the physical machine or the bare metal machine, where we directly install the operating system. But there are some limitations of using the physical machines or the physical servers. Machine and server both are same thing. The difference is if the machine is providing the service to a user, it is known as the server. So don't need to get confused. If a machine is providing the service, we can call it server. So there are certain limitations of these physical machines. There are problems which are associated with these physical machines or servers. What are those? Limited scalability. Limited scalability means we cannot increase the size of the hardware. There are limited options available, and for that we need to shut down the machine first. High maintenance cost. They're very expensive to maintain. They contribute to resource wastage. Suppose we need only a light-weighted application, but for that we need to run the complete server, we need to install the operating system there, and then we can install the application there on the operating system so that we can use it. So that application we could have installed on a lightweight server, but if we install it on a machine which is having a lot of hardware resources, so in that case it can contribute to resource wastage. There is no multi-OS feature available, although we can install multiple operating systems in different partitions of the hard drive, but generally we do not do it on the servers, or we don't do it in the data centers. We use only one operating system there on the server. Limited disaster recovery options. In case something goes wrong with the physical machine, your data is gone. So disaster recovery option is limited. Space constraints are there. You need a room, a table, chair, and air conditioner, a lot of other equipments. High energy consumption, because you are required to use a lot of additional tools, additional you can say equipments, so they contribute to the higher energy consumption. Deployment time is long. First you need to install the operating system, then you need to install the application, after that you need to configure it, so it takes a lot of time. Lack of flexibility, they are not flexible. Obsolete hardware is a problem there. Vendor lock-in periods, again a problem. So there are there are a lot of problems which are associated with the physical machines. Like backup and recovery is very complex and time taking. So in order to address these problems, we have a solution, that is the hardware virtualization. Hardware virtualization is the hypervisor based virtualization. There are two types of virtualization options available for us: hardware virtualization and the operating system virtualization. Hardware virtualization means we are virtualizing the hardware, and the software virtualization means we are virtualizing the operating system. So the containers that we are using nowadays, those are the type of the operating system virtualization. We will talk about it when I will start containers, I will start Podman. Now first here we will start with hardware virtualization. Hardware virtualization involves creating virtual machines on the top of the physical machine, with each virtual machine running a full operating system and a virtual hardware components. So how does it work? A hypervisor, whether it is type 1 or type 2, it sits on the top of the hardware and abstracts the physical resources like CPU, memory, storage, allocating them to the each virtual machine as needed. So what we are doing, we are actually using a tool here which is known as hypervisor. It may be type 1 or type 2. Type 1 means bare metal, means this tool is already available with the hardware, like VMware, SCSI, EXXI, Microsoft Hyper-V, Zen. And type 2 hypervisor means it is a software which we can manually install in our host operating system, like Oracle VirtualBox, like VMware Workstation. So if the hypervisor tool is built in your firmware, that is the type 1 hypervisor. If you are installing a software for the virtualization like Oracle VirtualBox or VMware, that is type 2. So what this hypervisor actually does, suppose we have a physical machine, that means we have the hardware resources like motherboard, CPU, ROM, RAM, secondary storage, network interface controller. So we have hardware resources on our machine. On that physical machine, we install the operating system. It may be any operating system like Linux, Windows, Mac. On the host operating system, we install or use a tool called the hypervisor. What it actually does, it virtualizes the entire hardware resources. Suppose we have 16 GB of RAM, and out of this 16 GB, 3 GB is used by the host operating system. So we have 13 GB of RAM available with us. So what this hypervisor will actually do, it can virtualize this RAM so that it can run other operating systems on it. So we can use a few amount of this virtual RAM in one operating system, some amount in other, some amount in the other operating system. So in the same way, the entire hardware resources are virtualized and used to run the virtual machines. So on this hypervisor, we can further install the guest operating systems. So we can create virtual machines there. Like we created VM1. On this VM1, we install the guest operating system. And on this guest operating system, we can install the applications. Similarly, we can run multiple virtual machines at the same time on the same hypervisor and host operating system. Like VM2, there we can install the another operating system, which is the guest operating system. And on that particular guest operating system, we can install the further applications there. So what we are doing here, we are using the host operating system to use the hypervisor, and this hypervisor actually virtualizing the hardware resources so that we can run the virtual machines there. So this is known as the hardware virtualization. We are virtualizing the hardware here. If we further virtualize the guest operating system to run the containers, so that is called as the software virtualization. We will talk about it at the end of this training when we will start the containers. Okay, now let's proceed further. So what we are going to do, we are going to use type 2 hypervisor here in our machine. Either we can use VMware Workstation or we can use the Oracle VirtualBox, so that we can virtualize the hardware resources which are available with our machine, and we can install the virtual machines there. Okay, I already have VMware Workstation which is installed in this computer. You can have a look at this. This is the VMware Workstation 17 which I downloaded from internet, and here with the help of this hypervisor I am running the multiple operating systems there. Multiple virtual machines are there: RHEL 9.3, Windows 11, Docker client, RHEL 10, Docker Swarm Manager, Docker Swarm Worker. So multiple virtual machines are there. Now let me show you how can you actually download this type 2 hypervisor. So if you have sufficient resources, sufficient hardware resources in your machine, you can go for VMware Workstation. Just a minute. Okay. So what are the hardware requirements for this training? Your machine should have either Intel i3 or higher CPU, or you can go for Ryzen 3 and higher. Either Intel i3 or AMD Ryzen 3 or higher CPU. RAM 8 GB or higher. Storage 80 GB or higher. An active internet connection. These are the requirements for this RHCSA training. If you have a personal computer which is having this much resources, it's good. If you don't have, then you can create your account on AWS or any other cloud service provider, so that you can create the machines there and you can practice. If you are looking, if you are thinking to purchase a new laptop, then you should go for at least Intel i5 or Ryzen 5 and above. You should go for at least 12 GB or higher RAM, and 128 GB or higher hard drive. So if you are looking to purchase a new machine, then you should at least go for this configuration, which I mentioned here. Because we need to run at least one machine here at the time of practice, and at the time of labs, we need to run at least two machines. Okay. Now, I will show you how can you actually install the hypervisor in your machine. So either you can go for Oracle VirtualBox, or you can go for VMware Workstation. You can visit this website, and here you can download the Oracle VirtualBox. If you are using the Windows host operating system, you can go for Windows host. If you are using Mac, you can go for Mac. If you are using Linux, you can go for Linux. Since I'm using Windows, I will go for Windows host. It will download a file in your machine. You need to execute this file and install this software in your machine so that you can virtualize the hardware and you can run the virtual machines there. Okay, this is how you can download it. Or if you want to go for VMware Workstation, you can go for VMware Workstation. You can get it from this page. VMware Workstation Pro download. You can download it from here. You can download the setup file. You can run the file. After that, you will find this software installed in your machine, and there you can create the virtual machines. I will show you how can you create the virtual machine there. Look at this. I have successfully downloaded and installed the Oracle VirtualBox in my machine. Let me remove these machines from here. Okay. Now I will guide you how can you install the RHEL 10 operating system there in Oracle VirtualBox. So what you would need, you would require to download the RHEL 10 ISO image. You can write RHEL 10 download beta ISO. Visit the very first link. Go at the end. You will find Red Hat Enterprise Linux 10 beta. This one. You need to download this file. If your machine architecture is 8664, you can go for this one. Or if you are using ARC64, you can go for this one. Generally, in 90% cases, we have these machines. So we can download this ISO image, 6.46 GB. You need to download this ISO, third one. Download it. You need a very powerful internet connection to download it because it is about 6.5 GB in size. And you can place it somewhere on your machine. Like I have it here. This one. I already downloaded it. I will share you the link of this image. I already have it on my Google Drive. I will share the link with you. You can download it from there as well if you want. Now we need to install the virtual machine. So we will go here on this machine button. We will click on new. We will mention the name as RHEL 10. In the ISO image section, we will browse this image. We will go to the location where we actually saved the image. We can select it. You can mention the username which you want to use. Like I can write here Vikas Nehra. You can mention the password which you want to allow which you want to allocate to this user, like this. Then you can specify the hardware, like how much memory you want to allow to this machine. 2 GB is by default. How many CPUs you want to allocate, whether you want to enable EFI or not. The disk space which you want to allow, 20 GB is by default selected there. And after that, you can create on finish. So this is the process where you can follow these steps to install the RHEL 10 in your Oracle VirtualBox. Same procedure you can follow on VMware Workstation. Now let me guide you with VMware Workstation. We already have VMware Workstation installed in our machine, and we already have the RHEL 10 ISO image with us. We will click on File, New Virtual Machine. So it will open the wizard. You can go with the typical or the recommended option. Click on Next. You can select I will install the operating system later. Select Linux here. Here you can select RHEL 10 if it is available. If not, you can select RHEL 9. Then you have to give a name to this machine. Let's mention as the name as RHEL 10. Click on Next. The minimum disk space is 20 GB. If you want higher, you can mention the number there, like 30, 40 or whatever you want. Then you can click on Next. After that, you need to click on Customize Hardware. Here you can select the memory and the CPUs. How much memory you are actually allocating to this virtual machine. You can adjust it. I don't have any problem with the memory if I go for 4 GB. So it depends how much memory is actually available, how much resources are available with your machine. I have 32 GB of RAM in this machine, and out of 32, I think more than 20 GB would be free. Let me check the system information. Here you can find the RAM size as 32 GB, and out of 32, almost 20 GB is free. So I don't need to worry about the memory. I can easily select 4 GB. The number of processors. So I can use the number as 2 and 2 cores per processor. So in total, I can have 4 processor cores. Then we need to select the ISO image path. So we have to click here, use ISO image file. We need to click on browse. After that, we need to select this RHEL 10 image, which we have already downloaded from internet. Click on finish. So our machine is ready. But we need to install the operating system first. So we need to power on this machine. So this machine will boot up with the help of the ISO image, which we are downloaded from the internet. Click here in this window. Select the first option with the help of the arrow keys. Install the RHEL 10. Press enter. It will take few minutes. You need to wait here. You can look at this. Files are loading on RAM from the ISO image, and these will help us to start and use the installer. Installer is running. Okay. Look at this. So installer is running. First of all, we need to select the language. Select English here, then select the respective countries where you live. We are living in India, so we will select India here. Click on continue. So it is a simple warning. This is a beta ISO. So we can click on I want to proceed button. Here, look for the localization. In the keyboard layout, India English is already selected. We don't need to connect to Red Hat. So we can skip this one. Then installation destination. If you know how to create the partitions manually, you can go for the custom storage configuration. Here you need to create root, boot and swap partitions manually. Since you are new and you do not have any idea how to create the partitions manually, so you can choose automatic here. Okay. We will talk about the partitioning in the storage section. You don't need to worry about it. In language support, English India is already selected, so we don't need to worry about this option. Again, the installation source, it is also auto detected, so we don't need to make any changes here as well. Kdump is already enabled. Kdump means kernel dump. It is a feature. So we will talk about the kernel dump in the upcoming sessions. Again, you don't need to make any changes here. Time zone, you can select your respective time zone here. In our case, Asia, Kolkata is already selected. In the software selection, you can go with the server with GUI, because in the beginning, we need the GUI as well, so that I can show you the comparison between the GUI and CLI after running the commands there. So we are going with server with GUI. If you have limited resources, you can go for the minimal install. It totally depends on your choice. At this option, you will not have the utility of running the GUI there. So we will go with server with GUI. Host name and network, it is already enabled. You don't need to do any changes here. In the hostname section, if you want, you can mention the machine hostname, or if you leave it blank, that's fine. Here in the user settings, you need to define whether you want to enable or disable the root account. So I'm enabling the root account. Generally, we disable the root account for security reasons, but you can enable it in the beginning. And you need to define the root password. So I'm going to assign the password to the root user, and I'm going to allow the root user to log in through SSH. What is SSH? We will learn in the upcoming sessions. Just skip it for now. We are allowing the root user so that root user can remotely log in through SSH. That's it. Go back, click on done. Now create a normal user. So let me create a user with the full name as Vikas Nehra, and the username is Vikas Nehra. I'm going to assign administrative privileges to this user, so I'll keep it checked. And I'm going to set the password to this user as well. Click on done and click on begin installation. So this process will take some time in installing the operating system from the ISO image. And once the installation gets completed, we can use the machine. So we already have a machine for RHEL 10 here. We can power on this machine. Once your machine is installed, please make sure you take this snapshot. Just take this snapshot like this, because every time whenever you make the changes, the configuration will get disturbed. So again, you need to create a fresh machine. So every time you don't need to install the operating system manually, you can directly restore the machine from this snapshot which you have already taken. Take this snapshot. Once you're done with your work, you can restore it. So it's very fast and easy to use. And in the beginning, we are supposed to make the mistakes. So that's why we are using the virtual machines. I'm not recommending you to deploy the operating system physically on your laptop or on your PC. That's why I give you the introduction of the virtualization before actually installing the operating system there, because virtual machines are easy to manage. You can create multiple virtual machines as per your own requirement. You can delete them, you can remove them, you can take the snapshot, you can restore them, you can do whatever you want with a fraction of clicks. But if you do the same task on a physical machine, it would be very difficult and time taking. So I will personally recommend you only use virtual machines for the practice, and I will recommend you to take the snapshot in the beginning once you install the machine. Okay, so we have a machine, we have already taken the snapshot. Let's restore this from the snapshot. Look at this. This is our RHEL 10 machine. It is getting restored from the restoration point. This is the first look of RHEL 10, and this is the terminal where we can actually execute the commands. So on this terminal, we are logged in the shell. This is a shell. Let me check which shell we are currently using. So we are using the bash shell. Bash means born again shell. And this is the shell prompt. What do we call it? It is the shell prompt. In the shell prompt, the first name, it represents the username from which user account we are logged in the machine. This is the @ symbol, which represents or which separates the user from the host name. Then comes the host name. This is the machine name or the server name or the device name where you are currently working. And then this sign represents the working location where you are currently working in the machine. So you are currently working in the Vikas Nehra's home directory. So the tilde sign is actually representing the home directory of this Vikas Nehra user. Let us suppose if we move to some other location like TMP directory, you can see now /TMP is mentioned there instead of this tilde sign. So this is representing the present working directory where you are currently working. And this $sign, it represents the normal user account. $sign means the user is normal user. But if a hash is written over there, that means you are having the super user privileges. You are either having the root user access or you have the super user access. So hash means admin or the super user or the root user. Let me show you. If I switch in the account of the root user, the shell prompt will get changed. Look at this. Now a hash or the pound sign is clearly visible there. It means the user is root user. And here also you will see root is written over there in the username on the same local host machine, and the tilde sign is showing the root user home directory. Okay, so this is the shell prompt. If we use some other shell like sh, the prompt will get changed. Look at this. This time we are using the sh shell prompt, so the prompt is different. Okay, this is how you can log in into the machine. We are using the local terminal. Local terminals are represented by this /dev/pts. If we want to log in remotely or from any other machine, what can we do? We can do SSH into this machine, and for that we would require the IP address. So this is the IP address of this machine. And if we want to log in into this machine remotely, we can use a tool known as PuTTY. PuTTY is a tool which you can use to remotely do SSH. Or you can use this tool, MOBA Extreme. It is very popular. You can click on session, you can click on SSH, you can mention the IP address of the machine, 192.168. What was the IP address? 2299.128. 229.128. You can specify the username and you can easily log in into your machine remotely. So this is the same machine, but we are logged in from a tool called as MOBA external. Okay, let me show you the shell. We are using the bash shell. Let me show you the uname-a command output. We are using the Linux machine, which is running on RHEL 10. The kernel version is 6.11. It is the same machine which is running here in the VMware workstation. If we want to power off this machine, we can easily power it off from this tool. How? Simply mention here init 0. As soon as I will press enter, this machine will power off. Look at this. So we are able to manage the machine remotely using a tool, MOBA Xterm or PuTTY. In the industry, you will not use this tool. You will use PuTTY only. So if you want to use PuTTY, you can download it from internet. PuTTY download. You can easily download it. Let me show you how it actually looks like. Look at this. This is the tool. Let me show you how can you log in into your machine using PuTTY. Let me start the machine again. So here in the host name, you will mention the IP address 192.168.229.128. Click on open, accept, login as root, provide the root password or the user password of the account with which you are trying to log in. And this is how you can log in into your machine. But I don't like its interface and the font size, and it is having a limited features as compared to MOBA Xterm. So that's why I prefer MOBA Xterm, because that tool not only supports SSH but the other protocol as well. Like if you want to use SSH, you can do SSH, you can do Telnet, RSH, XDMCP, RDP, VNC, FTP, SFTP. All of these features are supported here, which are actually not available on PuTTY. So personally, I feel MOBA Xterm is better, but you can use either of them. In companies, we prefer PuTTY. For your own learning, you can go for MOBA Xterm. Okay, guys, and let me power it off again. So that's it from my side for today's session. If you have any questions, you can ask me now.